Good evening, good afternoon, good morning, depending on your respective time zones. This is Statistical and Geospatial inside YouTube. We are meeting again in lesson number 23, which is about application of a standard normal distribution for probability calculation. By the end of this lesson, you'll be able to apply the standard normal distribution to execute probability calculation using the concept of a standard normal distribution. Example, a biology test has a mean score of 75 and a standard deviation of 25. What is the probability of scoring above 80? Step number 1, calculate the z-score. The z-score is given by x minus mu over sigma, where x is the raw score, it is equal to 80, and mu is 75, and sigma is the standard deviation is 5. By substituting these values in the formula, you'll get a z-score of 2. Then you go to the table to find the z-score, the area covered, or the probability for the z-score of 2. So in the table, this is 2, and this is the probability, which is the area covered or the area under the z-score of 2, which is equal to 0.9772. Now, the z-score here, the probability of x equal or less 80, which is 0.9772, this is this area. And the shaded area here is the area for the probability of x greater than 80. And you know that the total area under the curve is 1. So you subtract 1 from this, you'll get the shaded area, which is equal to 1 minus 0.9772. You'll get 0.0228, which is 2.28%. Therefore, the probability of obtaining a score above 80 is 2.28%. Another example is to get the probability of value being within a certain range. Using the same test scores with the mean of 75 and the standard deviation of 2.5. What is the probability of a score being between 72.5 and 77.5? We need to get the probability of getting a score which is between these two numbers here. First of all, let us calculate the z-score for 72.5, which is equal to 72.5 minus 75 over 2.5, you get minus 1. And for 77.5, the z-score is 77.5 minus 75 over 2.5, you'll get a z-score of 1, which is plus, which is above the mean. Now, you go to the table to find the probability, for the z-score minus 1, which is the area actually under z-score minus 1, and this probability in the table is 0.1587, which is the probability of getting a mark which is equal or less 72.5. For z equal to 1, the probability from the table is 0.8413, which is equal probability of getting a score which is less or equal 77.5. Then in step number 3, you have to subtract. You subtract the smaller probability from the larger one, which is now here. The larger one is 0.8413 minus 0.1587. You'll get 0.6826, and this is actually 68%. In the interpretation, there is a 68% probability of getting a score which is being between 72.5 and 77.5. The result aligns with the empirical formula, which is saying that approximately 68% of the data is within one standard deviation of the mean. Thank you.